We now discuss the solution of a problem from the section Sets, Relations and Functions. The given question in the examination is on sets. This question has appeared in the joint entrance examination main held on 25th June 2022 in the second shift. The given question is, let A be a set consisting of all those x belongs to the set of real numbers such that mod of x plus 1 less than 2, and the set B is equal to the set of all x belongs to R such that mod of x minus 1 greater than or equal to 2. Then which one of the following statements is not true? We are given four options. Option A minus B is equal to the open interval minus 1 to plus 1. Option B minus A is equal to R minus the open interval from minus 3 to 1. Option C, A intersection B is equal to the interval minus 3 to minus 1 closed at minus 1 end. Option D, A union B is equal to R minus semi-closed interval 1, 2, 3 closed at one end. We are given a set A is the set of all those x belongs to R such that mod of x plus 1 less than 2. And the set B is given as the set of all x belongs to R such that modulus of x minus 1 greater than or equal to 2. Then we have to find out that statement which is not true, For that purpose, we have to compute, we have to see A minus B, B minus A intersection B, A union B. That means three of them are true and one is false. And we have to find out that statement which is not true. We now discuss the solution of the problem in detail. We have the set A and the set B. Now, A is equal to the set consisting of x belongs to R such that modulus of x plus 1 less than 2. This can be written as mod of x plus 1 less than 2 will imply minus 2 less than x plus 1 less than 2. Agreed. Now subtract minus 1 throughout. Then you will get minus 2 minus 1. That is minus 3 less than x less than 1. So minus 3 less than x less than 1. That is the open interval from minus 3 to 1. That is A. Agreed. B, set of all x belongs to R such that modulus of x minus 1 greater than or equal to 2. This we write it as, remove the mod, then we write minus of x minus 1 greater than or equal to 2 and plus of x minus 1 greater than or equal to 2. So minus greater than or equal to 2 plus greater than or equal to 2. So minus of x minus 1 greater than or equal to 2 multiply throughout by minus 1, then the inequality will be get reversed. Then you will get x minus 1 less than or equal to 2 and the second one remains the same. X minus 1 less than or equal to minus 2. So multiply throughout by minus 1, then you will get x minus 1 will be less than or equal to minus 2 because the inequality is get reversed. Agreed. Now we add plus 1 throughout in this. If you add plus 1 throughout, then x less than or equal to minus 1. If we add plus 1 throughout, then it will be x greater than or equal to 3. So x less than or equal to minus 1 or x greater than or equal to 3. Now x less than or equal to minus 1 means the interval minus infinity to minus 1, it is semi-closed, closed at minus 1 end, and this will give you 3 to infinity semi-closed, closed at 3 end. Because it is R, it is union. So minus infinity to 1, 1 closed, union 3 to infinity, 3 closed. So that is your B. Agreed. Now to discuss A minus B, B minus A intersection B, B minus B, A union B, all these things, we require a geometrical representation. That is, we represent these things on a real numbered line. So we got A and we got B. We continue in the next slide. Right, we have A, open interval minus 3 to 1, and B, the union of two sets, two intervals, minus infinity to minus 1, closed at minus 1 end, union 3 to infinity, closed at 3 end. So let us take, this is the real numbered line for this first set A. So the whole real numbered line is here, represent. This is minus 3, not included, so open, minus 3. 1 is also open, and in between there's the blue one is the open interval minus 3 to 1. And all those real numbers which are not included in this open interval, let's write it as denoted by dotted line. So this is the dotted one. So these are the elements which are there in A, which are not included. Minus 3 and 1 are not included. Okay, to go for B, let's take the real numbered line again. This is minus 1 included and 3 included. Agreed. So minus infinity to minus 1 means all those numbers to the left of minus 1, including minus 1. So this will come in red line, yes. And 3 to infinity, 3 is included to infinity. So this union this. Agreed. In between it is not included, therefore a dotted line. Agreed. Now we have a and we have a B. Representations are known for us. Now let's look at our options, because our goals are to be set up. So first of all, the most easiest thing for me is option C. Let me check. A intersection B. C, A intersection B. Option C, A intersection B. So A intersection B. A intersection B. That means the common between A and B, that is these ones, that is the bold-faced lines. That's the commonality. So what is common? What is common? So is it this element is included here? Included, it is also included here, but it is not included here. So it will be 1 to minus 1, 1 to minus 3, minus 3 to minus 1. Minus 1 is included, minus 3 is not included. So this is minus 3 to minus 1, the interval, closed at semi-closed interval, closed at minus 1 end, which is true because minus 3 to minus 1, the same thing is here, therefore it is true. But we have to find out which is not true. So this is, so look for the next easiest, A union B. So take option D, A union B is equal to A. So A union B consists of all those elements which are either in A or in B. So suppose now you see here, these elements are in B, these elements are in A. Either A in B means these two here. So from here to here, and either A or in B means this one right to 3. right to 3. So what is included here? So it is minus infinity to 1 open interval. Why 1 open? Because it is here, it is open. So we take this one. So here it is included 3 to infinity. So union is A union B. This is also written as from R, remove this portion, that the dotted portion. What is the dotted portion? Here 1 is not included. So in the dotted portion it is included. 3 is included in A union B. In the complement, 3 is not included. Therefore, this is same as R minus the semi-closed interval 1 to 3 closed at one end, open at 3 end. So that is the one. So again, it is true. So the option D is also true. So let's get into the next one, the A. Let's take the A. A minus B is the set of all those elements which are in A but not in B, which are in A but not in B, which are in A, which are in this but not in this. That means here the bold-faced line and here the dotted line. That is this one is in A but this is not in B, and up to this A minus B, and here this is the only portion, that is the elements in A are here which are in A but not in B, means this portion only. So minus 1 is included here not, so which are in A but not in B. So it is open. You have to take open minus 1 to open 1, because here it is not there, it is open. Here it is included, so which are not there in B, therefore minus 1 you should not take. Therefore it is the open interval minus 1 to plus 1. Yes, it is given again. It is true. Obviously all these three A, C, D are true. Therefore obviously D will be not true. So let's see how it is. Let's look at D, option D, that is B minus A. All those elements which are in B but not in A, which are in B but not in A. That means this portion. B but not in A, B not in A. So these elements which are in B, not in A. So these elements are in B but not in A. So B minus A will be what? B minus A will be minus infinity to minus 3 up to this, because here it is included. And union, here the commonality is there. Here there is no portion of B at all. So elements in B but not in A will also include this. That is 3 to infinity. That is the closed interval 3 to infinity. Minus infinity to minus 3, closed at minus 3 end, union 3 to infinity, closed at 3 end. So now if I want to write, because the answer for this is R minus, so minus 3 to 3 plus 3. Minus 3 is included here, plus 3 is included here. Therefore it is a R minus the open interval minus 3 to plus 3. But here it is given as R minus 1 to 3 closed at one end, which is not the same. Therefore it is not true. This is not true. So D is not true. So our answer to this question is option B. This is not D, option B. Here R minus of minus 3. But here in B, it is B minus A is equal to R minus the open interval minus 3 to 1 only, minus 3 to 3. In the earlier discussion, I was pointing towards the D. This is not correct. Now b minus a is r minus the open interval minus 3 to 3. So compare, this is option B we are talking about. B minus a is equal to r minus the open interval minus 3 to 1, which is not same as this answer, this one. So therefore option B is not true. The answer for this question is option B. The answer for this question is option B. So that is the detailed discussion of the solution of the problem on sets from the section sets, relations and functions. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.